This is the fourth in a series of videos in which I am showing some cheap Chinese kits. So these are the sorts of kits you buy on eBay for just a few pounds. I paid £4.49 for this kit delivered, and it's a small robotic kit. And I'll go through in this video assembling it and then make a rough assessment as to whether or not it was fun. Now remember, these videos are meant just as fun. They're not meant as a full review of the product, and it's also a bit of a shout out to the guys that put these kits together. Shipping something like this from China for just a few pounds with all the parts and the effort that goes into putting these together is very impressive. And while the quality may not always be particularly high, trying to get anything like this in the UK directly would be almost impossible, and some of these can be fun. So that's the point of these videos, is to see if I enjoy putting them together. Now before I start assembling this or unpacking it, I just want to respond to an excellent comment that was made in the previous video in this series, and that was somebody was having difficulty, or saying it was difficult to solder the cheap boards that come in kits like this. And I don't know if this is a cheap board in this kit, I haven't seen it yet, but yes, some of the boards that are provided are extremely low quality, and the plating on them is very poor quality. And he was saying he's tried all sorts of things, using isopropyl alcohol to clean them and all sorts of things. And what did I recommend? Now, I very rarely, if ever, clean PCBs before I start assembling them, unless they, for some reason, have some clear contamination on them. It shouldn't be necessary. Modern solders should be able to solder to even low quality boards. Some are more tricky than others. So I thought what I'd do before I start assembling this is just quickly look at some information about soldering. Now there are hundreds or thousands of videos about soldering, so I'm not going to do a tutorial on soldering. Let me know if you want one, but this is just really intended as some tips for how to deal with low quality boards. Now the first thing, which I can't stress enough, is get a decent soldering iron. It doesn't necessarily need to be one of these. These are a bit expensive, especially for just a hobbyist, but Dave over on EV blog did an excellent video on these. And if you're going to spend money on something when you're starting out, spend it on a soldering iron. That might seem a bit strange. A lot of people just buy a cheap mains powered soldering iron, and I use one of those for decades, and they're fine. But if you really want to do a lot of this type of work, then a decent soldering iron makes a huge difference. And the difference you will see is quite remarkable. The difference between a cheap soldering iron and a good one is it can be astounding. And it's not necessarily just the price. Some cheap soldering irons I've used have been better than like the mid-range ones. Now these cost hundreds of pounds, so you might not want to go to this extent. But really the sorts of advantages you get with something like this are speed. So this is now in hibernation mode, it's cooling down. It might normally take several minutes for a standard type soldering iron to heat up, but these are direct heated irons. So if I take this out of the stand, you'll see the speed at which it heats up. So it's now up to temperature. I didn't change the video, I didn't speed it up, that's just how quickly these things heat up. Okay, so that's the first thing, is get a soldering iron that has an exceptionally good thermal capacity. You want one where when you put it onto the board, the outer surface of the tip isn't going to immediately cool down, and that's one of the biggest problems, and that's what I want to try and get across in this video. It's more about the temperature of the joint you're trying to solder than anything else. It's a bit like when you're doing reflow soldering in a reflow oven. The temperature is very important, especially with modern solders. They're not as forgiving as the older solders. So I'll get the iron out of the way and just do a few quick demonstrations to hopefully get the point across. So I've got a board here. I'm going to just move the camera down so you can hopefully see a bit clearer. I don't know quite how much of this you'll be able to see, but hopefully you'll see enough for me to make the point. Okay, so the first thing before you start soldering is try and figure out what the solder you're using needs. You might think they're all the same. I've got 3 different types here. Now in theory you should be able to solder all of these the same, and they're all supposed to be similar temperature range solders. Normally there will be something on indicating the temperature range that you're supposed to use, but it is important, it does make a big difference. And the problem you'll get is if you have a soldering iron where the solder is not at a consistent temperature for the joint you're trying to make, and it varies from joint to joint, then you're going to get poor results. And I've had soldering irons where I could solder maybe 5 joints, but then the iron had cooled down to the extent where I had to wait for several seconds for it to catch up. And what I'll do is just give a quick demonstration as to the variation you'll get. So we'll start off with this solder. And again, I'm not going to give any shout outs for particular solder types. It comes down to what you're doing and how you're using them. So we'll start off with this solder. I'm going to set the iron at 300 degrees. And if I start trying to solder with this, then what you'll notice is that initially it's a nice bright solder joint, but then it will go cloudy. So it's now gone cloudy. If I heat up the iron, so I'll take it up now to 365, and we'll try again, then it's staying a lot shinier. I don't know how well you can see this. Okay, but also if you solder more quickly, the joints will be brighter. And so you saw the one at the end that I did that was very quick, it's very shiny compared to the first one that I did. Again, I don't know if you can see this. So the longer you leave the iron on, the more you're going to boil away the fluxes and whatever from the solder. So you saw that the one I've just done that was much slower is duller than the first one. Now that's going to come down to the type of solder that you use. So again, a different type of solder here. If I do a solder joint, notice it's very bright and it stays bright. If I do a slower joint, it still stays bright even when it's cooled down. Also, the temperature is not critical. I'll go down to 290 degrees, do the same thing again, stays bright. Do a slower joint, it stays bright. So in other words, this solder is far more forgiving than the first one we looked at, and it depends on the type of solder you use, but the first thing to do is figure out what the best option is for the particular solder you're using. Once you've done that, then you'll find that the results you get are far more predictable. Now of course, for this to be useful or to work, you need an iron that you can not only set the temperature on, so a temperature controlled iron, but also one that has a very good thermal conductivity, so the tip of the iron does not change temperature as soon as you start to solder. And that these irons are extremely good. This is a 120 watt iron, very small tip, but it can provide up to 120 watts. And so that means it's got a huge thermal capacity, and not only that, because the heating system in this is right at the tip of the iron, which is why it heats so quickly, it's able to control the temperature very accurately. And that's where you'll have most of the problems if you're getting poor soldering. It's just you'll find the temperature of the joint is wrong, and it is either that you're not matching your iron to the solder you're using, or it's just your iron is not really up to the task. So unfortunately in that case you might just have to replace the iron. Again, I can't stress enough, if you have money to spend on something, buy a cheap scope and a good iron, not the other way around. Okay, so back to our robotics kit, and I'll get this opened and we'll see what's in the pack. Now, as far as I know, this robot's supposed to follow lines, so it's an optical guided robot kit. So we'll see what's in here for starters. So a couple of motors and gearboxes. Okay, probably not the highest quality you're likely to find. It makes a bit of a horrible noise, and now it won't turn at all, so I may have broken it, but we'll see how that behaves later. A couple of wheels with some O-rings as tyres, a battery holder. Let's have a look inside the little bag of components. As I said, I paid under £5 for this delivered, so I'm not expecting a lot, but as I said, this is more about the fun element rather than necessarily the quality. Okay, now this board does not look too bad. It's not ultra high quality, of course, but yeah, it looks to be reasonably well made. It's not a good quality finish, but yeah, it doesn't look too bad. Okay, so we'll look at the instructions. Okay, so it looks like it's just a simple left-right control circuit. So we'll see what's involved in building it. Let's see if there are any instructions. Oh, it's even got a track for it to follow. So, okay. Instructions are all in Chinese. Now, people have commented on these that you can download the instructions for various of these kits off the internet, but I'm not doing that with these kits. I just want to try and assemble it directly out of the box and see if it's possible to get it working without any outside assistance, so to speak. So the first thing we need to do is try and figure out exactly what we're looking at here. So I start by putting the tyres on the wheels. That's the easy bit. So that's the first one. Okay. And the next thing is I will assemble the components, electronic components, onto the PCB. And as usual, the actual values required are marked on the PCB itself. So we'll start with the resistors. I want video on me sit through me popping these into the board, but I will show me soldering a couple simply because I've been asked to do that. So I'll get these inserted into the board to start with and then get back on camera. Okay, so I've inserted the resistors into the board, and what we'll do now is just flip it over and I will get them soldered and we can move on to the next components. Okay, so that's all the resistors soldered in place. I'll just trim off the excess leads. Clean up the mess. Okay, and so we'll move on to the next components. The transistors seem to be the same type, and looking at the schematic there's only one type, so we don't need to worry about mixing those up. There's only a couple of capacitors, so we'll get those put in place next. Make sure they're the right way around. It's actually quite a nice board to work on. The layout's quite nice and the components fit nicely, so that whoever's laid it out has made a nice job of getting the component footprints correct. I'll put the transistors in as well. Trying to work it on the camera here, so I can't really see what I'm doing, so bear with me if I look a bit cack-handed doing this. This is why I don't normally video soldering. It is a bit tricky working around the camera, but not too bad. Okay, so they're in. I'll get these soldered. So this board is soldering quite nicely. It needs a bit more temperature than a high quality board, but it is actually taking the solder quite well. Okay, so that's those parts fitted, and so the next step is to figure out where the remaining components go. And looking at the board and the schematic, we have 4 LEDs. Actually shows 5 LEDs on the schematic, but there's only space on the board for 4. I think they've just done away with this power indication LED. So we've now got some components to fit down here. We've got the IC, a couple of pots and a switch, and then we've got 4 LEDs to fit. Now the silk screen for these is on the bottom of the board, and I suspect that these will need to go on this side, and we'll just quickly check that. So the motors are going to be attached using the tape. If we then fit one of the wheels, so the battery compartment will be up here, and of course it can't run this way up because the battery would drag on the ground, so it has to go this way up, and so these components will have to go on the underside of the board. So we'll get the mechanical parts fitted before we do that, but before I put the motors on, I'll just fit these components down here. I won't show any more soldering. I'm just going to insert all these into the board and get them soldered in place, and then we can attach the hardware, get that connected up, and then finally fit the sensors. Okay, so I've got those components fitted, and the next thing I'm going to do is fit the 2 motors. Before I do that, I'm just going to tin the contacts that they solder onto. I have already attached the wires. Now, I don't really know which way around these are supposed to be connected, and the diagram doesn't say. Now they do appear to be driven left and right motors, and because I'm assuming these gearboxes are identical and we're flipping one over, then in theory that should automatically reverse the direction of travel anyway. So I think we can just wire them both the same way around and it should work, but it may run backwards because we don't know which way the wires are supposed to be connected, but we can always swap them over if it doesn't behave itself. So I'll get some solder put onto these pads. Okay, and the next thing, I'll do the same thing with the power connector. Again, that's not through hole, it's just a couple of solder pads that the wire from the battery holder connects to, and presumably the wire for that comes through that hole. Okay, so next thing we'll do is fit the 2 motors. So they will go on something like this. There is a legend on the silk screen, so we just need to make sure we get them reasonably square. If we put them off at a cocked angle, then it's obviously going to go around in circles when it shouldn't. So we'll try and get them fairly square. Okay, and so what I'm going to do now is try and get it as square as I can, and in the right relative location according to the silk screen. Okay, that looks to be square. I'll do the same thing with the other one. Okay, so that's those fitted, and next we'll attach the battery compartment. So we'll get this on the right way around, so I want it coming off at this side. Okay, I'll shorten these wires, get them soldered to the board, and I'll also solder the 2 connections from the motor to the pads. I'll just guess at the moment which way they're supposed to go, and then get back on camera and hopefully fit the last few parts. Okay, so that's the motors fitted and wired. As I say, I don't know if this will run backwards or not. We can always swap them over if we need to, and the batteries are now connected. I don't know quite what's involved with adjusting these pots yet, and next thing I'm going to do is fit the wheels. Okay, so I've got it assembled to this point, and it's now obviously clear what the bolt's for. It's the front guide, so presumably I need to fit this so that it rides along on the top of this nut, so this it's going to be level. Okay, so the next thing is to fit the sensors. Now I'm sure it does say somewhere in the instructions what height these need to be fitted, but as I can't read Chinese, I'm going to guess. So because I can always make them shorter but not longer, I'm going to start by fitting them so that they are too long, or probably too long. So I'm going to just fit them so they're a few millimeters up from the surface. So I'll fit these so they are something like this. I'll fit the sensors so they are about the same height. I think it's just reflective feedback. This is going to emit some energy and then it will be picked up by the sensor. So I don't think it's going to be fairly, particularly critical, but I'll set it about this height. I'll try and get them both the same, and we'll see how it looks. Okay, so that's the robot finished. I've just set the sensors to an arbitrary height at the moment. They may need adjusting and I'll trim them once they've been set up properly. And looking at the schematic and the way it's laid out, I suspect that all that's going to happen is when there's no reflection from either sensor, the motors will come on, and as there's a reflection from each motor, it will turn the opposite motor off. So I'll fit some batteries. Probably going to have to play with the adjusters to get it to work. Make sure it's turned off. Okay, grab an adjuster. Now of course it might run backwards because I don't know which way around the motors were supposed to be connected, but we can always swap the wires over if we need to. So turn it on. It does at least appear to be going the right direction. Okay, I would have expected both motors to come on initially. Okay, well it doesn't appear that it's smart enough to drive both motors at the same time, so it looks like it's going to be one or the other driving. Okay, so let's try my track and see what happens. Hours of fun for the whole family, but it is quite clever. It's less than £5 and you can have a robot that's capable of at least following a predefined path, and it does actually work quite well. It hasn't lost its way yet. And let's try seeing if it can go the other way. And it can. So, okay, well as I say, it was I think £4.49 delivered. It's taken me probably half an hour to assemble, and it is quite interesting to watch. It's doing quite a complex thing here, but a very simple machine. And if you're starting out in electronics, or even like me, if you've been doing it for decades, then it's still something fascinating to watch in a machine like this. So I would say it was well worth the money I spent on it. I'm not sure there are many components here you could use for anything else. The sensors, the light dependent sensors, are possibly useful. A dual op amp, but as I said, you could in theory, oh it's gone mad, you could in theory, never see that again, so if that turns up at your house you can keep it. So as I say, in theory you could adapt it to do other things. Once you've got a chassis to work off, then you can obviously mess about with it, change the settings, see if you can improve its performance. See if I can find where it went. So yes, I'd say that was worth £4.49p.